We said in the previous video that the square root of x was continuous over the open interval for sure from 0 to infinity, and then we focused on how we closed that off at 0. And there are several functions that really we can just kind of say intuitively are continuous across their domains. And fortunately for us, it's most of our major functions. We almost have to build a piecewise function to really kind of break this down. So the following types of functions are continuous at every point in their domains. And so it is important that when we talk about these functions, that we are focusing in the domains of these functions. If we're outside of the domain where the function is undefined, we already know that an undefined value is going to give us a break in continuity. So as long as we are in the domains of these types of functions, we're able to say that they're continuous across their domains, which would give us some continuity over an interval. The first major type of function that is going to be continuous across its domain are polynomials. Things that look like the form 3x to the fourth minus 7x squared plus 8x minus 2. If I have something like that, that particular function, you already know there's no issue there in terms of substituting in values of x. It's continuous across its entire domain. The same is true for rational functions, and again, this is where it's important we say that we're in the domain. So if we describe a function, let's call it f of x, as equaling a g of x over h of x situation, as long as we are talking about where h of x is not equal to 0, which again would exclude that value from the domain, that function is going to be continuous across its domain. The same is true as we just saw in the previous couple of videos with functions involving radicals. So if I have a function, we'll call it f of x, and I'll say the nth root of x. This applies to more than just square roots. We're able to say that these functions are continuous across their domains, and that's what we saw in that previous couple of videos. Our trig functions are continuous across the domain. So that includes sine of x and cosine of x, which don't have any exclusions from their domains, but some of the other trig functions that do have exclusions in their domains, like tangent of x, secant of x, cosecant of x, and cotangent of x, all 6 of those major trig functions are continuous across their domains. The other 2 types of functions that we really haven't gotten to experience a lot in calculus so far, exponential functions are continuous across their domains. So if I have something in the form of f of x equals a to the x, where a is some constant value being raised to a variable exponent. A couple of disclaimers on this one. A does need to be greater than 0, and then also a cannot equal 1. Otherwise, nothing really happens. 1 to any power is just going to be 1, and so it's actually just a constant function for that value. And then the other type of function that is going to be continuous across its domain are going to be logarithmic functions. And there are some domain restrictions for logarithmic functions, but if it takes the form of f of x equal log base a of x, and we get the same restrictions here, a cannot be negative, and it also can't be 0 for that matter, and the same was true for exponentials. A cannot also equal to 1 because you kind of get the same issues right there. So as long as we're talking about the domains of these types of functions, and we pretty much just listed off all the major types of functions that we're going to endure, we are going to be able to say that they are continuous for all points in their domains.